Hi, I'm Sameer Dharur, and here's our paper on sorting VQA models, contrastive gradient learning for improved consistency. This is joint work with Purva, Dhruv, Devi, and Ramprasaath. Imagine having an image like this and putting it through a commonly used visual question answering model like Pythia, first asking it a higher order reasoning question like was this taken in the daytime? The model would answer yes, which would be correct. Now ask it a sub-question, which we define as a question that's essential to answering the reasoning question and only relates to the lower level perceptual concepts about the image, like is the sky bright? The model would answer no, which would be incorrect. This canonical example here highlights a common problem of consistency often seen in most state-of-the-art VQA models. This right here is the guiding motivation for our work. In addition to a reasoning question and sub-question, what if you also had an irrelevant question, which we define as a question that relates to the image but is not essential to answering the reasoning question? We ask, can VQA models be made more consistent by using relevant sub-questions and irrelevant questions for a given reasoning question? In order to evaluate this, we make a representational choice of using gradcam vectors for each of our questions, which at a high level is a gradient-based function of the question, image, model's parameters, and the answer. To enforce consistency, we align the gradcam vectors of reasoning questions with sub-questions and distance them away from irrelevant questions. Now here's what that looks like. In the training stage, for each batch of a reasoning question, sub-question, and irrelevant question on a given image, we first enforce a cross-entropy loss with respect to the ground truth answers for each of these questions. Next, we compute gradcam vectors for each of these questions and enforce a contrastive gradient loss, which is intended to bring about our desired alignment. We find that our approach leads to better ranking of sub-questions over irrelevant questions, improved model consistency, and improved visual grounding. Most state-of-the-art VQA models often rank irrelevant questions higher than sub-questions while answering a reasoning question. Our approach improves this on a range of metrics like mean precision at 1, ranking accuracy, mean reciprocal rank, and weighted pairwise rank accuracy. Across all of our experiments, we compare our approach with two strong baselines of Pythia and Squint. This improved ranking of sub-questions over irrelevant questions also leads to improved model consistency, which we define as the frequency with which a model correctly answers an associated sub-question, given that it correctly answers the reasoning question. We find that our approach improves model consistency by 6.5 percentage points over Pythia and 3.2 percentage points over Squint. Here's a qualitative example of that. For this particular image and the reasoning question of did the train cross the bridge yet, the baseline model of Pythia first gets the ranking of the sub-question wrong and also its answer, whereas our approach of SOrT first improves the ranking of the relevant sub-question and also answers it correctly. And finally, our approach also leads to improved visual as quantified by comparing gradcam heat maps with ground truth human attention maps obtained from the VQA human attention dataset. As evaluated on the metric of Spearman rank correlation of these heat maps, our approach outperforms both of its baselines. As a qualitative example of this, for this image and the question, is the baby using the computer? Our approach is the only one which focuses on the appropriate visual concept of the baby's hands operating the computer, which is required to answer this question. In summary, VQA models are often inconsistent. We introduced an approach of sub-question oriented tuning to rank sub-questions higher, and this leads to improved ranking of sub-questions, model consistency, and visual grounding. Thank you very much.